Next slide. Power of a power. Simplify. 6 to the power 2 to the power 3. That means this 6 to the power 2, it multiplies itself 3 times. So let's write it out. 6 to the power 2 times 6 to the power 2 times 6 to the power 2. Now each of these 6 to the power 2, that is 6 times 6. So what do? 6 times 6, 6 times 6, 6 times 6. How many 6 are multiplying with each other? 6 sixes. That is 6 to the power 6. Did we really have to do all this work? No. The rule says if you have any base a to the power m to the power l, the answer is simply a to the power ml. The powers multiply each other. Now if you had more than just 2 powers, for instance, a to the power m to the power l to the power q to the power t, and so on, you can keep on going. All you will do to get the answer is multiply all these powers by each other. If I had more powers, all I would do is multiply it with this product over here. Cool? Cool. All right, let me erase this so we can work on problem number 15 and 16. So now that you know the rule, what would be the answer for number 15? What is number 15? B to the power 5 to the power minus 2. Just to show you explicitly, what it means is this: 1 over b to the power 5 squared, which means 1 over b to the power 5 times b to the power 5, which is 1 over b to the power 10. And this can be written as b to the power minus 10. See that? We could have simply multiplied this 5 by minus 2 and could have gotten this minus 10. So instead of doing all this work, and honestly, I could have done even more work than this if I wanted. I could have written out b to the power 5 as b times b times b times b times b times b. I lost track of how many b's I have said already. But I don't have to, because these rules, they make our life so much easier. Instead of us writing out a repeated multiplication, who knows how many number of times, we have these shortcut methods. So b to the power 5 to the power minus 2. Simply multiply the exponents with each other and you get minus 10. Let's do that for problem number 16 now. Simply multiply the exponents with each other. And the exponents here are 2, 3, 4. You have 2 squared. That 2 squared is raised to the power 3. And that 2 squared raised to the power 3 is raised to power 4. That means this part here is multiplied with each other 4 times. And then each of those 4 products will have a repeated multiplication of 2 squared 3 times. That's already 12 factors there in the product. Then in each of those 12 factors, 2 is multiplied by itself 2 times. So that is a total of 24 factors. Do you want to write it out? I sure don't. So I'm going to simply write it as 2 to the power 2 times 3 times 4. And that is equal to 2 to the power 24. By the way, if you were asked to evaluate 2 to the power 24, what would be your answer? Let's try it. If we were asked to evaluate it, it will be 16,777,216. That is 2 to the power 24. Quite a big number, huh? Moving on to next slide. Mixed exponents rule. We looked at rule if we have a to the power m times a to the power l. The base is same for these 2 powers that you're multiplying. All you do is add up the exponent. So that gives you a to the power m plus l. Now let's twist this problem a little bit. divide this by a to the power k. That means the right-hand side also gets divided by a to the power k. What do? Now you use the power rules for quotients. This will give you a to the power m plus l minus k. Simple, right? I hope you're seeing the pattern here. If you understand it, it's simple, it's easy. If you don't understand it, it's super hard. And hopefully you understand it because you have seen it all work explicitly now. Alrighty. Number 17. In the numerator, we have x to the power 2 and x to the power 5 multiplying each other. So that gives you x to the power 2 plus 5 divided by x to the power 3. So what do we get? We get x to the power 7 over x to the power 3, which is x to the power 7 minus 3 equals x to the power 4. Did I need to do all this work? No. Once you are comfortable with these power rules, then you would simply do this here. X to the power 2 plus 5 minus 3. You could do it all in one step, and your answer will be equal to x to the power 4. All right. Next one. M to the power 2 to the power 3. Power of power. This gives you m to the power 2 times 3 times this m to the power 3. M to the power 6 times m to the power 3. Now you use the product rule for exponents when the base is same. It gives you m to the power 6 plus 3, which is equal to m to the power 9. Cool? Ready to move on to number 19? Well, unfortunately, I do not have a live feedback here, so I'm going to move to number 19. If you have not understood any of these problems, good thing. These are recorded lectures, and you could pause them, you could rewind it, you could rewatch it if it still does not work out. If you still do not understand something, ask me in the comments section. All right? All right. Moving on to number 19. Numerator, 2 to the power 4 to the power 2. That gives us 2 to the power 4 times 2 at the top divided by 2 to the power 3. What do we get? 2 to the power 4 times 2 is 8 for the numerator, and the denominator is 2 to the power 3. That gives us 2 to the power 8 minus 3, which is equal to 2 to the power 5. So answer is 2 to the power 5. So by the way, these are your answers here. This is 17, this is 18, this is 19 here. Got it? All right. Next slide. Different bases with same exponent rules. Okay. So here you go. Excuse me. Let me work out one of these completely. So the logic for the rule, that makes sense for you. So 3 to the power 7. I would write that as 3 multiplied by itself 7 times. Here we go. That's 6 times 7. What are we doing next? Next, it is multiplied by 2 to the power 7. Let me write it underneath it here. 2 times 2 times 2 times 2 times 2 times 2 times 2. Do I have 7 of these? Yes. These are multiplied with each other. Now, watch this. 3 times 2 is 6. This 3 times 2 is 6. 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 Multiply them. How many 6's are there? Here you go, 7. So we have 6 to the power 7. We could have gotten this very simply if we realize that even though the base is different here, the power is same. So we could write this as 3 to the power 7 times 2 to the power 7, it can be written as 3 times 2 to the power 7, which is 6 to the power 7. Simple. So here you go. I'm about to erase this. Let's say you have a to the power L, b to the power L, c to the power L, d to the power L. A, B, C, D. These numbers could be different in general. They do not have to be, but they could be. All you have to do is multiply these bases and raise them to the common power L. That's all you have to do. All right. Let's move on. So number 21 is 3 times 2 to the power 7. 6 to the power 7. Number 22. That's a bit tricky now. You have 4 squared is cubed and 3 is cubed. So 4 squared is 16. 16 cubed times 3 cubed. That is 16 times 3 cubed. 16 times 3 is 48. So it's 48 cubed. Let me put these answers in blue boxes. 23. Again, it's different. Not so much. Watch this. We can write number 23 as 8 to the power 8 times 1 over 2 to the power 8. That means it is 8 times 1/2 to the power 8, which is 4 to the power 8. We could have done this very simply. From here, realizing that the power of the numerator and the denominator is same. It is 8 over 2 to the power 8, which is 4 to the power 8. But here I showed you explicitly how it works out. So the answer for number 23 is 4 to the power 8. Here you go. I want you to think outside the box to solve these problems. But at the end, box in your answers. Why am I saying this? I don't know. Just sounded cool. Number 24 is a neat hybrid of 23 and 21. Watch this. We have 8 to the power 3 times 6 to the power 3 over 4 to the power 3. So there are a total of 3 bases there, 8, 6, and 4. But they all have the same power. They all have the same exponent, 3. So all we need to do is write it as 8 times 6 times 4. The bases are multiplied or divided however they were in the original problem. And we are going to raise this to power 3. What do we get? Well, 4 goes into 8 2 times. So we have 2 times 6 is 12. 12 to the power 3. This is our answer. Here we go. Last set of problems. Different looking bases, simplify or evaluate by rewriting each expression with a common base. Okay, so here is your goal. You rewrite each expression with a common base and then after that simplify it or evaluate it. Alright, I think we can do it. Number 25. 2 to the power 3 times 4 to the power 2. Number 25 has two factors. 2 to the power 3 times 4 to the power 2. Which of these two bases can be rewritten in terms of the other? Obviously 4. So what we're going to do is we're going to write this as 2 to the power 3 times. This 4 can be written as 2 squared. So 2 squared is further squared. What do we get? 2 cubed times 2 to the power 4. Add up the exponents and you get 2 to the power 7. Easy. Once you know how to do it, everything is easy. And sometimes to learn how to do things, it takes a lot of investment of time and perseverance. Moving on to number 26. 3 to the power 4 times 9 to the power 2. Hopefully you all know which of the two bases, 3 or 9, can be written in terms of the other. So we have 3 to the power 4 times 9 squared. 9 can be written as 3 squared. And this is now squared. So what do we get? 3 to the power 4 times 3 to the power 4. This 4 here is coming by multiplying these two 2's. What do we get? 3 to the power 4 plus 4 is 3 to the power 8. Okay. Number 27. 8 cubed over 2 to the power 4. 8 can be written as 2 cubed. 2 cubed is further cubed. Divided by 2 to the power 4. We get 2 to the power 9 at the top divided by 2 to the power 4 at the bottom. And this gives us 2 to the power 9 minus 4 equal to 2 to the power 5. And I did not box in my answers here, did I? Last one. Last but not the least. Problem number 28. Smallest base is 2. So our goal here is to rewrite 32 and 4 in terms of 2. So 32 is 2 to the power 5. And that is being squared times 2 squared divided by 4 is 2 squared, and that is to the power 3. What do we get? 2 to the power 10 times 2 to the power 2 divided by 2 to the power 6. That gives us 2 to the power 10, okay, plus 2 at the top, that is 12, divided by 2 to the power 6. What does this give us? This gives us 2 to the power 12 minus 6. 2 to the power 12 minus 6, which is equal to 2 to the power 6. So the answer is 2 to the power 6. So here we have now solved all the 28 problems of the post-test on exponents. So far we have discussed two topics of pre-algebra. The first one was order of operations. The second one is exponents. Third one I'm going to do is on the number system. Hopefully these lectures, this style of lecturing is helpful to you, where you first do a self-assessment, second a review, and then third a post-assessment after reviewing the concept. And after doing the post-test, which is the second self-assessment, we go over the solutions. I will see you again very soon in the next lecture. Until then, have a good one.